Let's solve some stuff. All right, so I'm gonna lower that just a skosh. Actually, I'm gonna lower it there. All right, so first of all, let's bust it wide open. So the idea is we have this little guard, and the guard moves and only turns right when they're ready to get out of there. So fortunately, I made a little matrix helper that I think will be good, but I probably need to create some more methods for it. So we'll see how that goes. Do 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 do. Yeah. Okay. So we're gonna copy this guy. Actually, we're gonna start with this, and we're gonna see if we can get that answer. So I'm gonna go ahead and open up cursor. No, I'm not gonna use the AI. I just have all my settings in here. So, yeah. In fact, let's make sure we disable cursor tab. Okay. So now we're gonna go ahead do a D6. D6. We're gonna do example.txt. Boop, boop. We're gonna do solution.ts. We're gonna say this needs a little more. Need a little more space. We're gonna say cool. Oh, I needed a -A. Cool. So now what we're gonna do is we're gonna generate the matrix first. So first we're gonna say cool. So we're gonna call solution on my example. Oh, and I need to say, I kind of want to do a pipe because it's starting to look ugly. Oh, we got NaN. Oh, because I didn't need this. That was derpy. Okay, so now we got our matrix, and I should be able to get that print text. So there we go. That's what we're working with. The idea is we're going to have to take this thing, boop, 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 traverse up, and then boop, 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 traverse right, and then boop, 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 traverse down. So I think that the goal here is going to be let's see. Well, first we need to find the cell. So we're going to say I love these because it gives me an idea of like what functions would be useful. We'll say Excel equals dot find all cells where, and here I could take in my cell, and here I could say cell dot value equals caret. So we're going to say the guard dot at 0. If not guard, throw new error. Could not find guard. Obstacles equals matrix dot find all cells where cell dot value equals pound. Cool. And now let's just go ahead and first let's log the guard, make sure it found that. And we could probably just do the guard dot position. Tag works. Whoops, I'll just do position. So that's gonna be 6-4. Is that right? 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4. No. 6. Oh, row 6. Whoops. 1, 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4. Cool. So that's right. And then the obstacles, just to get an idea. And we'll map over those and get the position. Okay, so it looks like we have those. That's good. Okay. So now the idea is we're just going to go up. And I'm trying to think of, do I actually need to physically move it, or do I just keep going until I hit the edge of the map? I think this is probably really easy to do without like, coming up with a hit edge equals false, while hit edge equals false. We need to let a direction equals, we'll say, we're gonna go up. Actually, I'm gonna use the same lingo that I'm using, which is north, east, south, whatever. Okay, well let's, so now what I'm gonna have to do is I'm gonna say, all right, we're gonna keep going up. So we're gonna say the position equals, and this is gonna be a position. We're gonna say that this is gonna equal guard dot position, and we could get the obstacle positions is gonna equal obstacles dot map for each obstacle. Poop out the obstacle dot position. And now what I should be able to do is we're going to start off at the guard position, and then and we're going to have a count, I guess. Oh, we'll have to say, really we should do positions. Positions, position array, start off with a guard position. So now my position is going to equal positions dot at -1. We're going to start by going north. We're going to say, let's make a, Mm-hmm. North goes east. East goes south. South goes west. West goes north. Indexed at direction. Cool. So this is my current position. We can call it that. Current position. And basically, we're going to say, let's move. So now we're going to go up. So we're going to say next position equals we'll go, I'll do a TS pattern. I love TS pattern. Whoops. Oh, you know what? I think I might need to enable Dino. That's probably why I'm not getting my functions. We're gonna match. Next position is we're gonna get our direction. And I have the foresight that I'm gonna have to dump in the edge in there. Maybe not. No, because it'll probably be before that. Okay, match direction with north. We're gonna have to return positions, our current position, indexed at current position. If it's north, we're going to need to move up a row. So we're going to say current position dot indexed at 0. And actually here we're going to say current position, if not position cool. With north, we're going to return, and we could say this thing is a position. Probably will help TS pattern a little bit. If it's north, we're going to get current position 0 -1. If it's south, we're going to get current position current position 1. Okay. Then never eat soggy waffles. If it's east, we're getting my current position +1. If it's south, we're getting our current position +1. And if it's west, -1. Okay. Oh God, I hate that formatting. We're just gonna slap a Dino. I have it in a array test. There's a Dino format ignore. See if that does it. Now. I did spell it right. It's just oh, I don't need the @ sign. Maybe it goes here. Oh yeah. So much nicer. Then we're going to say cell at position is going to equal the matrix dot cell at next position. We could say if not cell at position, break the loop. We've done it. We could also say if cell at position dot value equals this, then we're going to have to say that my hit, I don't know that I need this hit edge, while true. Can it be so? We're going to say my direction equals that little helper I made, get next direction. Get next direction. Huh? Cool. And now, I'm missing an exhaustive here. Oh, that's screaming at me. Number array is not assignable to, might need an as const on there. Come on. Happy? You happy, TypeScript? Are you freaking happy? I suppose so. So if we hit a wall, we're just switching directions. That's our turn. And then if we don't hit a wall, we're going to add the position. So we're going to say positions dot push next position. And if I did this right, we should actually converge. Hopefully. It's never reassigned. It's true. Let's see if we converged. Doesn't seem to be the case. So let's see how our position is changing. Do I need to restart it? Oh, it converged. Dude, if I get this fast, I'm going to be mind blown. So now we have to just return a unique array of all those things. So I'm just going to return, let's say, unique positions equals unique by positions, and we're going to return positions indexed at 0. Oh, wait. Unique by position. Oh, derp. Positions. Position. 0. Position. 1. Unique positions dot length. That can't be! It cannot be so! Alright, let's see if it actually works though. Which obviously I don't have yet, so let's get my puzzle input. It's a big fucking... This is cool. This is a cool problem. Okay. Will it convert? It's a Christmas miracle! While they're working, you borrow their fancy devices, step outside the lab from the safety of a supply closet. You time travel the last few months and record the nightly status of the lab's guard post on the wall of the closet, returning after what seems like only a few seconds. The historians, they explain that the guard to be too large. Wait, they explain that the guard's patrol is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place a new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. Whoa. Have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. What the fuck? Oh, man. Can't be placed at the guard's starting position. Next to the guard's starting position. What the fuck? Wait, so they're putting in a single obstruction. Okay. Holy shit. How do... Oh, man. Use 0 to mark the new obstruction. Pipe to show a position where the guard moves up and down. Oh, this might help a little. Up, down, and left, right. Oh! I think what you could do... Alright, so what you do is... You find parallel lines. If you could draw parallel lines, you found a fucking loop. I think that that's the trick. So basically what I need to do is find all the... Find where I could draw a rectangle. Maybe not. Option 2, put a stack of failed suit prototypes in the bottom right quadrant of the mapped area. So let's say we dump this fucking thing here. Put a stack of failed suit types in the bottom right quadrant of the mapped area. So you place this here. Then now the guard starts here. Boom, boom, boom. And then the guard goes boom, 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 boom. And that's just the loop? Wait a second. What is the loop here? He goes up, over, down, left, up, right. Down. Oh, no. Oh, no. Yeah, to there, down, left, up. I think that I am going to have to look for a pattern. In other words, are all loops going to be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4? I feel like that might be the assumption I have to make. Or can there be like a more complex loop? Like, is it conceivable? Oh, whoops. Is it conceivable that I could have a loop that's like, maybe I go up and then like I hit something here and then I go over and then I hit something here and then I go down and then I hit something here and then I go over. Let me just keep reading. This one, put a creative chimney up, over, down, left, up, right, down, left, up, right, up, what? Left, up, right, down, left, up, right, down. So this one's interesting because the path is, yeah. So I think that's what I need to look for is like, do I get the same sequence of 4 over and over again? And that sequence needs to be not, yeah, interesting. So basically I think I could do this with like a minimum sized queue kind of thing. So what I'm thinking is doing something like this. So I'm going to track the positions that the guard goes for each loop. I'm going to track the positions that the guard goes. And basically what I'm going to do is I'm going to start off, I'll dump a thing in there, a position, then I'll dump another position in there, then I'll dump another position in there, then I'll dump another position there. From this point on, what I'm going to do is I'm going to keep 4 in this thing. No, it's going to have to be more than that. So maybe what I'll do is I'll let this thing grow to 8. And the second this thing fills up with a pattern that is this and this twice is the second that we get this going. So this totally could be a queue. And yeah, that's the goal. That's what I'm gonna do. I'm gonna keep a queue, max size 8. So I think that'll work. We could just do custom with an array, I think. But yeah, so the idea will be when we push to this thing, its size will not exceed the max. So let's do, we're gonna call this I'm just gonna be easy, we're gonna call it a queue. And I probably will make a custom queue structure later. But our queue is basically just gonna be, it's just gonna be an array. So let's do this again. For now, always quick and dirty first. Copy that. Great. What don't I need? I still need to get this next position. I still need to traverse that like that. I still need my obstacle positions. But now I'm going to have to iterate all over all of this. So we're going to have to just go through each thing. So I'm going to have to say matrix dot for each, or I could do find all cells where for each cell. We're going to say if the cell dot value equals if my cell value equals or doesn't it has to equal, what are the, it has to equal a dot. Does not equal, so if it does not equal this, return false. Jesus. Then we're going to say now going to have to I think I'm going to have to dump this other code in here. Guard specifically guard, or not guard. I'm gonna need obstacle positions, and then I'll also need to add the cell dot position. Okay. These are all my positions, so this should still be a position array. And then we'll have to go through this whole logic again. And then the only thing that we'll really have to do is dump a Q on there, I think. That thing that I was talking about. We don't care about the unique positions. Well, wait. What's the metric we're going by here? Put a creative chimney squeeze prototype fabric. So then that we calculate this. You find that there are this many different positions. How many different positions could you choose? So we don't care about this. Because that's where we're getting our find all thing from. So the big thing is, this is not going to converge, is basically what we're going to say. So knowing that it's not going to converge, we need a criteria for which this thing decides to break. The criteria that we're going to choose in this case, I think, is going to be when that queue fills up such that 4 things repeat twice. So what I need to do is be like, here is my, we're going to call it a queue. We'll call it the queue. Unfortunately, we could just use the position tag to do this. In here, we'll generate that. And we need to make sure we're calling this on solution 2. Definitely don't want to be calling that on the real one. Well, I'm going to hold off on this because it's not going to converge yet. Basically what I'm going to do is I'm going to say I'm tracking all the positions. So now I still could just track all the positions. But now I have to just keep that queue going. So now when I dump my position in matrix.cell at get next direction positions.push. Okay, so it's I think all the juicy stuff is gonna be in positions.push. Right? Because now what I can do is I can say positions if so we're going to call this length is less than 8. We're definitely going to push it. And then what we're going to do is we're going to say if the position isn't less than 8, what we're going to start doing is checking it each time. So first we're going to check it. And we're going to check that it's going to look a little silly, but I wonder if there's a way to be cool if I made like a serial. I guess I could just do JSON stringify. As stupid as that sounds. I could say if JSON.stringify, and we could go positions.slice from 0 to 4. I always mess this up. If I go slice from 0 to 4, and then we're going to slice from 4 on. Yep. So if the halves are equal, we can just return true from this function. Else we keep going. Else we keep going. I think this might be what I need. Let's see. And then now we're not outputting anything. And outside of this while loop, we return false. If it ever makes it out of there. And then we're going to say that the obstacle positions never used. I did never use the obstacle positions. Oh, I didn't need it because of that. Right, I didn't actually need that. But, interesting. So that was wasteful. And then here, now I'm saying if the cell position dot value equals this, and now it's just going to be or if the cell at, or the position, cell at position is just next position if my next position equals, I should make a compare method, that'd be good. My cell dot position, just to make sure that's going all the way to the top. Cool. Okay. And this is really what we could return. We can just return this value. But for now, nothing. So this don't appear to be working that well. Because why? If my cell position value equals that, or JSON.stringify the next position is our cell position, in other words, that's where our block is. Otherwise, let's go ahead and log something just to kind of get an idea of what's going on here. First, let's see if we're switching cells. Are we just stuck on one? Only ran once? Oh, because the while loop's down there. Console.log. So what's going on here? Okay, oh, see, this is... And then if I go positions.length, or positions. Oh, I never pushed, did I? So it's definitely repeating the same thing over and over again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 8 long. Did I ever do an unshift? I realize I never did that. Definitely not. If the positions dot length is less than 8, we never modify the positions. If the positions are less than 8, push this. If they're not, if hows are equal. Otherwise, we are going to say positions equals, or we're going to say positions dot shift in, and we're going to say positions dot push our next position. I think that'll do the trick. I'm going to do some good old mutative code. Okay. So now, instead of logging the positions, I want to log when it collides. So the collision is going to happen when the next position Direction equals get next direction. Console.log. In here, we're going to change we're going to get our direction. We're going to get our next position. We're going to get my current position. Current position, but we're going to do current dot... Oh, wait, no. Current position will look fine. And let's log this. Boop. Okay. Oh, wait a second. Rather than the positions as the cue, I need the hit a walls at. So I need the... It's not about... The position stuff can stay, that's fine, but this isn't right. So no matter what, we're going to push that. But now what we're going to do is we're going to create a new thing. Not just positions. We're going to say the hit walls at position. And that's what we're going to be doing with all this shit. So if the positions dot length. So here's if the hit walls at dot length is less than 8. Here we're going to do the hit walls at, and here this is going to be the hit walls at, and then we're going to push our if the hit walls at dot push. This is going to be determined if the hit wall. This needs to also be hit walls at. Okay, so then what I'm gonna do is we're gonna skip all this. We're gonna take all this and we're gonna put it in where he hits the walls. Or she, I don't know. Hits walls at. If it equals this, then we're going to say what'd I do? And then in here, hit walls at dot push the current position. And then, yeah. Let's see what happens when I do this. Boop. Okay. Never eat soggy waffles. Well, that's good. It was at least doing that right. Northeast, southwest, northeast, southwest, northeast, southwest. Oh, I'm dumb. I could just do that. I could say if the direction cue. But that's okay. That'd be way easier though. So we're gonna do that. We're gonna say hit walls at is gonna be a direction array. Call this a direction array. No. If it's a direction array now, else shift r halves equals this is a funny way of doing this, and it will technically work. Could be is if oh no, that won't work. No, I was wrong. I need my positions back. Yeah, because it's always that would have been stupid because it's always going northeast southwest. No, never eat soggy waffles. Okay, but anyways, all right. So I still think this is the right idea. So why isn't it converging? Let's go ahead and just say we're gonna console log a little something juicier. Oh. We're gonna need to in here. I feel like console.log our hit walls of that and see what happens. So let's do that. Boom. Is it never hitting these walls? Something weird is going on here. Allocation failure. Oh, okay. Now I'm getting my hit walls at 19786132. Let's make it a little easier to read. Whoops. One nine. 7 8. You know what I've realized I could do is just and here 6132. Oh. There's an easier way of doing this than the Q. I could just serialize this. And then store it in a map and get the previous solutions. I guess maybe I could just specify a size and just do that. That's what I'll do. We'll specify Q size. So let's do that. Const Q size equals, let's make it 8 for now. I think that'll be fine for now. My assumption was wrong is what it is. So I had a bad assumption. But let's make it 8. Swap this out with Q size. And that way we can make this adjustable. And we're just going to store the previous solutions. So in other words, what I could do is we'll say let previous records is a new map of, we're going to say strings that point to it doesn't really matter what it points to, but whatever. That's fine. And then now what I could do is if the queue size, if it's less than the queue size, we're going to say serialize wall. And really I just need that map. I will say walls. And is going to take in a, that's going to be a position. And then now I can go to my my queue size. So if something is less than the queue size, where's that? Hit walls.length. So I don't like this. If cells in this or JSON my position. No, that's probably fine. And then here, if hit walls dot, it must be fine if it's not converging. So that must be doing its trick. If hit walls dot length is less than queue size, hit walls at dot push. So I do need to push that. And then once I hit my queue size, the goal is if the halves are equal, this is just wrong. We don't care about this, but we're going to say shift, we're going to push. So we're going to record that solution. So we're going to say previous records dot set serialize walls, hit walls at, and we could just set it to 0. It doesn't matter what we set it to. It really doesn't matter because if it exists. So here's where we're going to say if previous records, actually let's say key equals serialize walls, hit walls at. If previous records dot has the key, we're going to return true. Else, we are going to set the key to a value. And that should do the trick. And let's see. Let's put the queue size of 8. Is it still printing? I think it converged. Console.log result.length. How long will this take? I have no idea. It's a lot of math that it has to do. A lot. Oy. Because it's a big fucking... What do we got? We got... Oh, it's not that big. We've got 130 lines, and I don't know how long this thing is. It finished. 1957. Let's see if we got it. Please, 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 please. Oh, no way! No way! No way! No way! I cannot believe that. Hell yeah. Hell yeah, hell yeah, hell yeah, hell yeah. Oh my gosh. I always suck on the Matrix ones. Dang, these Matrix helpers be working. Huh. Thank you. Thank you.